Materials we'll be using for this is I'm going to be using the desktop software version 10.02.130.12. This is our current beta release software. So we're sending this out to beta sites. It is not released yet, but anyone in the software support engineering team or myself can provide you with a link to this desktop software so that you can start using this newest version. The 3D import option will need to be installed. I have 3 step files and a DXF file that I'll be using. I do have a note that using a mouse as we program will make this easier as opposed to the touch screen, but I have a few tips for using the touch screen effectively on the control without a mouse. So the screen layout of the new 3D DXF screen, the graphics screen, will have collapsible panes on the left, right, and bottom of the screen. On the left side, we see the new 3D import functionality, select functions, create blocks, snap functions, draw, actions, which we'll cover in more detail, as well as the graphics pane on the right side that gives us the ability to zoom, pan, rotate, select different views, and the toolpath verification window, which will then allow us to speed up or slow down the drawing, as well as the data block search, screen capture, and graphics settings screens. On the 3D import pane, we start with the select pane at the top, where we can select single entities or multiple entities based on the selections made. We also have there to chain selections, where we can chain entire contours with a single click, as well as toggle on and off the multi-selection. We can use the, excuse me, we can also set a filter radius and set a focus point, which I'll explain in more detail. The create block pane is where we will create data blocks. Okay, so this 3D DXF that's been out for a couple of years now is going to use these same, we're adding to these block creations. So 3D mold is currently added, locations, pattern holes. We've added another one called bounding frame that we'll go through, which creates a frame around an entire selection, as well as the snap options, the draw options here, used to draw geometry in a 2D. You can draw 2D geometry, but you can draw in a 3D workspace. So you can draw a rectangular frame and then switch views to the XZ or the XZ or YZ view, and then continue to draw so you can make 3D shapes. Actions pane include join, split, trim. We can apply chamfers and fillets to intersecting geometry. We can explode polycurves into the individual line and arc segments. And we can do a surface alignment to align our working coordinate system to a feature or a flat surface. Okay. The import pane is where we will import DXF and step files. It's important to note that we can import only .stp, .dxf, or .step files. We cannot import IGES or parasolids or STL files. So your file formatting is important, bringing it into WinMax. And then last, we'll talk about the layers, toggling on and off layers, creating new layers, and moving different pieces of geometry or models between the layers that you have available. On the select pane, we'll start at the top left with the single selection feature. To select geometry, you must select the arrow cursor key. It will highlight in blue, and then you can select single pieces of geometry, or press and hold the control key on the keyboard to then select more than one piece of geometry at a time. You can also toggle on the multi-selection checkbox to allow you to select multiple pieces of geometry around a part while rotating or moving it so that you can see those individual pieces of geometry. Window selection allows you to click and drag a window around your work part or your DXF file and select multiple pieces, everything that is completely contained within that selection window. Okay. You can select multiple pieces of geometry using the window select, regardless of whether or not the multi-selection box is checked. Chain selections checkbox will allow you to, with a single click, chain an entire contour as long as that contour is connected. And we have tolerancing that we will see in the 3D import settings window where we can set the tolerance for that chaining. Filter circle radius, when this box is checked, it applies a filter to any circle radius. This could be cylinders, this could be arcs, or it could be full circles. But once we set that filter circle radius, when we window select, it will only select arcs, cylinders, or circles that are within that filter circle radius value. We do have a key to set R. This key will allow you to select a curve or an arc, and when you press this set R button, it will automatically apply the radius of that feature to the filter circle radius. So once you've selected one curve, you could toggle set R and then turn the filter circle radius on and window select to select all circles, curves, or cylinders that are the same as what you have set that radius to using the set R feature. The focus setting, when you are using the ISO view, that focus key will align the drawing, the view, so that is what you're seeing. So it will center that feature or whatever you have selected and rotate the part to align that to the current view. If we select the settings key, let me back up right here. When we select this settings key, we'll get a drop-down settings window across the top edge of the screen. The settings window can be displayed in millimeters or inch and toggles between the two by using the inch and millimeter button or the unit button on the input screen or on the main screen of the control. So when you toggle that selection, just like we do on any of the programming screens or tool setup screens, it will also change the units that we're seeing here on this settings window. So there's no toggle within the settings window itself. You'll need to look to that main screen to make that selection. Keep in mind, it does convert all units when you change, so be mindful of what mode you're using. Some key settings I want to point out for the selection of geometry include the filter circle radius. So that's what we talked about on the last screen, where here we have it set to 5 millimeters. So when I window select, if the filter circle radius box is checked, we will then only select features with a 5 millimeter radius. We can set a tolerance for that. So if we have a little bit of error in some of the curves or arcs, we can open that tolerance up to an acceptable value so that when we window select, we don't miss features that may be just a little undersized or oversized based on the tolerance given. Other tolerance settings that I pointed out is the contour closure tolerance. This contour closure tolerance is for chaining contours. For chaining contours, the max tolerance on that contour when it comes in. Okay, the contour planar tolerance is for surface tolerancing, and then the max chaining distance when we chain contours using the chain selections option we're going to only bridge gaps that are no greater than 5 micron in this example. You can also set that filter radius by and the snap grid spacing here. So there's that, the filter radius, and then the snap grid spacing. When we talk about the selection options and the snap functions, we can create a grid where we can automatically snap to that grid, and this is where we'll set the spacing when we turn that grid on and off. Other things, if we want to display solid edges, if we load in a step file that doesn't have wireframe geometry associated with it, we could toggle this show solid edges on, and then we would see outlines on the edges of that solid feature or geometry. Under display modes, we have wireframe, solids, I believe in transparent. And then measure space. If we use the measure feature that's been available in WinMax, we can measure in screen space relative to the screen that you're in right there, or in world space to do 3D measurements in an ISO view. Excuse me. Moving on to the next pane, we're looking at the Create Block plane. On the Create Block plane, the soft keys that are available, you'll see that Frame, 3D Mold, and Position are grayed out right now, while the other features are available. The available soft keys are going to be based off of the current selection. So if you have a rectangular feature selected, Frame will be available. However, circle may not be, whereas contour or sidewall contour will be available with most all selections, as well as bounding frame, which is a relatively new feature for us. So the bounding frame creates a rectangular box around all the selected entities, whether that be 2D geometry or solid models. So if you'd like to create a bounding frame around a feature, select that feature and select bounding frame. Okay. Pattern holes and location holes is like what we have been similar to the original 2D DXF options that we have seen. And then a 3D mold data block, which will allow you to select an along contour and a profile contour and create that block from within the solid model or 3D DXF. Below the Create Block screen, we have Snap Options. Within the Snap Options, we can turn the grid on and off by selecting the grid key. The grid spacing is set in the 3D Import Settings window. So when you turn that on and off, it will automatically snap to each intersection on that grid. If you'd like to increase or decrease the resolution of the grid, again, the 3D Import Settings on the Selection pane. Snap to Object is the key next to that grid, the little cube, and when Snap to Object is enabled, you can cursor over an entity and snap to it based off of the selection in the drop-down menu below. In the example picture that I've got here, I've selected End, so that as the cursor moves close to this curve, it automatically puts the blue snap box on the end of that curve. If I were to move my cursor closer to the other end of the curve and click, it would automatically snap to the opposite end of that curve. So when you make that selection, you'll hover your mouse close and then click as soon as you see the blue box. Wherever that blue box is what is going to be selected. Snap options are none, point, end, mid, as in midpoint of a feature, center point, quadrant, and intersection. So here's my tip about the touch screen. When you're using the touch screen, if you're not zoomed in very close, that selection key can be covered over by your finger when you're trying to make that selection. So what I recommend that you do is go ahead and touch your finger onto the screen and then drag your finger close to the entity that you want to select. That way the mouse is selected, and as you drag close, you should see that box highlight, and when that box pops up, release the screen and it'll make the selection there. Okay, so you want to touch away from the feature, drag your finger towards it. Once you see that selection box where it needs to be, then you can go ahead and release your finger to make that selection. Okay. Note, using a mouse will make this easier, but not everybody has the ability to plug a mouse into their control. Okay. Below the snap functions, we have the draw pane. This allows us to create new geometry in the graphics window. So we can select line, arc, circle, point, or rectangle as of right now. Once you select the type of entity you would like to create, you can then click anywhere in the graphics screen or snap to a location where you want that feature to start. If you're creating a line and you have nothing to snap to begin with, simply create the line by clicking in the graphics window, moving the mouse to another place and clicking again, and you'll have created that line. You can then use the selection operation to select that feature, and the bottom pane at the bottom center of the screen, it will give you the information about that. So you'll see the start point and end point in X, Y, and Z. You can then modify that to whatever you want it to be. So if you don't have anything to snap to, or you don't have your snap grid on, the drawing is more of a free form drawing, and then you can apply the constraints such as saying I want the X and Y start point to be 0, 0, and then type in an X and a Y end point, and then when you select apply, it will go ahead and move that line to the appropriate values that you keyed in here. When circle and arc are selected, you will also have a radius where you can define the radius either by clicking on the screen when you create it, or by editing it using these input fields at the bottom center of the screen and using the apply key to apply those edits. Below drawing are the actions. The actions include extend entity, trim entity, join, split, transform, fillet, and chamfer solid edges. Those are two different keys there. You can explode a polyline, quick planar transform, and surface alignment. When you use these actions, you will approve or cancel. Also, if you have something selected you'd like to delete, the actions key is where the little trash can icon can be used to delete, or the delete key on your keyboard. So I'm going to go into a little bit more detail on these keys. Extending will allow you to extend a line or an entity to a point or to another intersection. Trimming allows you to trim another entity, to another entity or to a point. You can use the snap functions in any of these or freehand. Joining two entities will join the two entities together if you have two lines or an arc that connects with another arc. But it's important to note that if you join those entities, it creates a polycurve. If you have an arc, and you'll see this in my DXF example, that is broken into quadrants, if you select the two of the quadrants and you select join, it's not going to make that into one larger arc. It's going to create a polycurve. So some data block creation will be affected by this. Okay. Split entities allow you to split at an intersection point. When you use the split operation, when you select it, it will ask to select the splitting entity first. So not the entity that you want to split. You need to select the entity that crosses it, or the point where you want to split the entity, and then select the entity that you wish to split second. And again, when we get to the example programs here, I'll walk you guys through this again. The transform operation allows you to rotate or move the selected geometry. If you're using the transform action in the isometric view, you must have the snap to object enabled. Okay, so if you're in the isometric view and you select transform key is grayed out where it's not available, like what we see here, you simply need to go to one of the orthogonal views, one of the 2D views, or you need to turn your snap functions on, and that button will become available. Lastly, in that transform, when you're performing the transform, you'll have the input fields at the bottom center of the screen, and you can also scale geometry or models from this using this transform action. So there is no individual scaling window or a scaling field like we had in the Max 4 DXF. It will be performed under the transform action. So rotation, translation, or scaling will all be within the transform action. Chamfers and fillets simply apply a chamfer or a fillet between two entities. Okay, fillet being a curve, a chamfer being a line at a 45-degree angle. Okay, the size of that fillet and chamfer is set in the 3D import settings that we saw earlier in the presentation. So you'll set that, and it's a global setting, so it will remain set until you change it again. So if you chamfer 4 or 5 different corners or intersections, it will use that same chamfer on all of them unless you change it in between selection. After fillet, we have explode. So if you bring in a DXF or a model that has polycurves in it, you can select that polycurve and then hit explode, and it will break that polycurve into the individual line or arc entities instead of being a polycurve. Okay. If you join two entities together using the join feature, and you're having issues because it's a polycurve and not a line or an arc, simply select that entity and use explode to break it back into the individual lines and arcs that it was created from. Quick planar transform allows us to simply change the view of what we're seeing. So we can go from XZ to YZ. This is typically used for quickly reorienting a DXF drawing. So if you bring in a DXF drawing and it's rotated 90 degrees, or it's in the YZ view as opposed to the XY view, you can select that geometry and then click on Quick Planar Transform to allow you to flip it to another plane. Lastly, in the actions is surface alignment. Surface alignment aligns the part 0 coordinate system to a face. When we go over this, what that means is we can select the part 0 location or the part 0 coordinate system and then select a point from which we would like to be the positive x-axis, and then a second point to be the positive y-axis. So the origin point would be the first point, and then we'll give it 2 additional points which will define a plane and then orient the part 0 coordinate system to that new plane. Or you can do the same thing by selecting a solid face, and it will align that part coordinate system with that face. Okay. Lastly, on the 3D import pane, we will be looking at the import and export functions, and then below that layers. So Clear will clear all entities. It will delete everything that you have brought in and everything that you have drawn, if you have drawn any geometry in the graphics window. If you have a DXF file or 2D geometry, when you select clear, it will ask you if you would like to save any changes that you've made, and then you can save that out as a DXF file. The import key will allow you to open up a browser window or a Windows Explorer screen to select the DXF files or step files that you would like to load in. If you load a step file, it will give you a warning message and let you know that we cannot export step files back out. We can only export back out 2D geometry. So if you physically change the solid or delete a face, you'll need to re-import that or make a change to that solid outside the WinMax environment. The export key, like I said, we can export only 2D geometry or DXF files, wireframe geometry with the export key, and then undo and redo. I didn't add a caption because they're should be pretty straightforward. If you click on the wrong thing, you can simply undo. If you go back too far, you can redo the last action that you performed. So below the import and export is the last screen on that, or the last section of that, and that will show layers. When you load a model in, it will load in with the layers that were created, that were saved with it from wherever it was created. All layers will default to be visible. When you see the eyeball icon, the little eye, that layer is visible. If it's got a box next to it, that layer is hidden. You can toggle visibility simply by clicking your mouse on that eye icon or on that box, and that will toggle the visibility of that layer on and off. Here I've got just a few toggled on and a few hidden layers, so you can see that. Simply click on that eyeball icon to change the visibility. On the right side, the colors, if you click on that colored box, it will open up a color menu and allow you to change the color of everything, all the geometry on that layer. Okay, so simply select the layer that you want, and then select the color, and it will allow you to change that. The small settings, the gear icon in the upper right of the layers window there will allow you to add or delete layers. It will also give you options to move selected entities to an active layer. Now, we don't have anything currently that denotes what layer is active. So to select the active layer, you simply click on a layer, and that layer is active. Like I said, at this point, there's nothing that will tell you this layer is active. So if you have any doubt, you need to simply touch on one of the layers, just click on it, and then it is active. Okay? So if I want to take something from the print border layer and move it to the title info layer, I would simply select that geometry, select title info to activate that layer, and then open my settings, and then click on the selection that says move selected entities to active layer. And again, that active layer is the last selected layer. Okay.
Will be available at some point in time. I can't promise it.
Okay, guys, moving on to the right side of the screen, the graphics pane. This we've had for several years, ever since the Max 5 control became available. So these shouldn't look like anything new to you. So I've just kind of quickly summarized some of the sections here. Zoom, pan, and rotate. Again, rotation only being available in the isometric view. Zoom and pan will always be available. The soft key, the blue soft key with the arrows swirling in the center there, will reset to the active view. So it will fill the screen with whatever geometry is visible at the time. It will pan it back to the center, and like I said, it will set the zoom at a fill screen. Okay. Based off of which one of these zoom, pan, or rotate keys is selected, you can use the arrow keys to then pan up, down, left, right, zoom in or out, and then rotate around in the isometric view. Okay. The reset all key is similar to the reset view adjustments and will reset everything in the graphics window to the current view. Below that, opaque is just a toggle to toggle on or off the transparency of the solids or simulations. The measure key, when you're in a 2D view in either XY, XZ, or YZ, you can click and drag a line on the screen and it will show you the value of that dimension. It'll show you that. So if you turn your snap options on, you can click on the corner of a block and then cursor over and click on the other corner, and it will give you a window that shows you the measured distance. Okay. And then fill is fill screen. Fill screen will adjust the zoom and the pan, but it won't reset any rotations. Okay. And then lastly here, X, Y, X, Z, and YZ views, top, front, and right side views, as well as isometric view or the quad view will show all views. In the toolpath verification below, which will be right below the graphics keys, we have part, single, and tool. Again, these are the same way they've been since the Max 5 control was released. So we haven't really changed anything over here right now. But part, when you select draw or hit the blue draw button on the console, it will draw the entire part program. Whereas single, with the cube there, is single block. So you'll have to hit play for each data block in the program. And then tool, if you have tool selected, when you hit play, it will draw everything that's programmed up to a tool change. When you hit play again, and it will draw everything that the next tool does, and it'll stop at each time the program would change tools. Okay. Increase and decrease speed here. Again, this is more of a refresh rate than it is an actual speed of the simulation. So when you're set to max, you won't see the tool moving very fast. You'll see nothing for a couple of seconds, depending on the size of the program, and then it will render it all at once. Whereas if I have this set down to 1 or 2, we will see that update much more often, so we'll actually see the tool moving around the part. Okay? But if you have that set to max and you hit play and you don't see anything, don't be alarmed there. It's simply processing the entire drawing, and then it will render it once it's processed all the data. Okay? Below that is select and jump. This was referred to as data block search in the Max 4 control, but it is the same way it's been since the Max 5 came out, where if we select, excuse me, all right, where if we select a line of toolpath or a feature in the simulation view, we can then use the jump key to jump to the data block or to the NC line of code that programmed that move. Okay. So select the toolpath or the entity that you'd like to jump to, and then jump will become available. Okay. Below we have capture, high res, and the graphics settings. So the capture key was referred to as snapshot in the Max 4 control. It will save a screenshot of the current graphics window with the program. Okay, your program needs to have a name and needs to have a directory location, so you need to save that program from the program manager. And then when you come and select capture, it will save that screenshot with the program, and you can see that from the input screen. High res is a higher resolution. This high res setting is not something that you want to turn on when you're rendering the entire part. This would be more commonly used if you zoomed in on a particular feature. Let's say you saw faceting on the walls of a curve or a circle contour. You could zoom in closely on that and then select high res, and it will update the resolution for whatever is currently in the view. If you turn this on with the entire part rendered or have a large, complex NC program, that high res can really bog down the controls. So if you turn that on, it'll get sluggish. Once you leave the graphics screen, it defaults to turn that high res back off. And then lastly, the graphic settings. I didn't create a slide for the graphic settings. Nothing really in here has changed since the Max 5 control came out. All the 3D import settings will be accessed from the settings menu here. So all of the new settings will be from the select pane and will be in this settings window, whereas the settings on that graphics drawing here is going to be the traditional graphics window. Okay. So guys, what I'm going to do now is I'm going to go ahead and pull up my desktop software. I'm going to program through a few of these features, use some of these selection tools, and just show you guys how these work. Once we work through that, I'm going to open it up for questions. So let me switch my screens, and we will move on over to the graphics. So, okay. So now we're in the new WinMax graphics window. We're in the new WinMax graphics window, so now we can kind of look around and see some of these new features. So each one of these panes, each one of these panes, when you cursor or hover over one of the soft keys, it will prompt you with what that button is. So if you're not sure which one is snap to grid and snap to object, simply hover your mouse over that, and then you will get a text box to explain what that soft key is actually labeled as. Okay, we didn't put the labels, we went with icons to keep the screen nice and tidy there. Okay, so the first thing that I want to do, guys, is I want to import a DXF file. Okay, so I'm going to select import, and it'll open up my window where I have a DXF file and a few step files. Again, it shows only supported files, that being DXF, STP, and STEP. So let's select DXF Demo 1, and we'll hit open. This is the DXF Demo 1 file that is on every new machine on the D drive in the samples folder. So you guys, I'm sure, have probably seen this before. But we're going to start by cleaning this up and using the layers to do so. Again, I can expand and collapse these panes to have a bigger view and only show what I need to at a time. So we're going to come down here to layers, and under layers we can start toggling on and off the visibility simply by selecting that eyeball icon. Let's scroll down. There's the title info, center lines, notes we don't want to see. We don't want to see the border. And I'm going to also hide the dimension lines. So now I've cleaned this up to just the center lines of the two arcs of that part. And I can toggle those on and off. And if I'd like to change the color of that layer, I can use this box here and change it to, let's go with the red. And okay. And now I've changed the color of the layers of the entities on that layer. Okay. So now that we've cleaned this up, I want to make a couple of selections. First thing I notice is that my part origin is sitting out in space. It might have been over at the side of that title box. So what I want to do is I want to move the origin to the back left corner of the part, okay, or the top left corner on the screen here. So to do that, I'm going to turn my selection on, select pick. You'll notice that the cursor is now highlighted in blue. I'll bring my cursor down over the origin indicator and select it. Once it is selected, take note that the X, Y, and Z position of it are relative to, excuse me, the X, Y, and Z are 0 because that is the origin, okay? These are relative to the way that the DXF file came in, and then any other features will be relative to wherever we put this origin. So I'm also getting prompted down at the bottom of the screen with some text, now that I've made a selection, to tell me what to do next. This is similar to the black text you see at the bottom of the programming screens, part setup and tool setup screens, input screens. So again, we're keeping that text to prompt you along. So now I need to go ahead and put that on this corner. Now notice right now I have nothing snapping, so if I want to snap to the end of one of these lines, I need to turn my snap options on. So I'm going to select snap to object, and then within my drop down, I can select how I want to snap. I want to snap to the end of a line, so I'll select end. And notice as soon as I hover over that line, it puts that blue selection box at the end of that line, whichever end you're closer to. If you select an arc, again, it'll snap to the end point of that arc. So when you're using the touch screen, you may need to, say, click right here, press and hold, and drag your finger over. And as soon as you see that box appear, release the screen, and that'll make the selection. But a mouse is going to make it significantly easier for that. So we'll snap to this back corner by clicking on that line, and it has moved the origin for me. Okay? So now that I've set the origin where I want to, now I want to go ahead and create a few data blocks off of this DXF file. So we're going to select this line. I'm going to turn my snap off. I'm going to select this line. Notice that when I select a line or a feature, the other selection is no longer selected. So right now I'm in single selection mode, okay? I do not have multi-selection checked right now. So if I want to select more than one entity at a time, I'll select multi-selection, and now I can check each one of those 4 sides individually. Or if I clear all here, cancel the selections, I can turn on chain selections and click anywhere on that frame, and it chains all 4 sides. So it selected all 4 sides for me, okay? Again, that's using the chain selections. Now that I have selected the outside perimeter of that, I have the options to create a frame, a contour, a bounding frame, or I could use this as the along or profile contour of a 3D mold data block. So I'm going to go ahead and select a frame, and it asks me to confirm the transform plane Z direction. So by opening my graphics and going to the isometric view, I can see that it oriented that incorrectly, okay? So what I'm going to do is simply click on it and allow it to reorient. So now I've got the Z-axis going in the correct orientation, and I'll go ahead and hit the green check to approve that. Now it's giving me a note to please click on the top of the feature for Z start, but it lets you know that this is an optional step. This is a 2D file, so I'm just going to hit the green check and approve past this step, and it lets me know that the data block was then created. So when I go to the review screen, that one was in there previously. we have our mill frame data block, just like what we would have gotten from the 2D DXF file. Within that, I've got all the dimensions programmed. I simply need to select a tool and select my milling type to machine that part. Give it a Z start, 10 millimeters, 1 millimeter, 600 millimeters, and we'll go about -6 millimeters for this, okay? I'm gonna go back to the graphics window. And now that I've programmed that, I can draw this, I can simulate this. So by pressing the draw key, there we see our simulation, just like what we would have seen if we had programmed it conventionally with the part programming screen. So that's just a simple data block creation on 2D geometry, okay? I can hide the simulation if I need to select more things, simply by toggling the selection layer on and off on the left side of the screen. I can also clear that by selecting the clear key on the graphic settings on the right side, okay? Now, when I clear it, I can't just turn it back on. I have to re-simulate that data block to go ahead and get that data block simulation to show again, okay? Now, while we're here on the DXF, I'm going to go ahead and clear my simulation, go back to the XY view, and I want to show you a few of these actions here real quick, just to make sure you guys understand what some of these different actions do. So, I'm going to go ahead and turn my selection on and turn off chain selections so that I can select this curve. Notice that this curve is from where it intersects the line to where it intersects the other line. If I need to break this curve up into two separate entities, I can select split. Now, I'm going to cancel my selection because when we use split, as soon as I click on it, again, notice it kind of pops that comment down at the bottom center of the screen. So select the splitting entity. So I'll select this line. I can click on it. I click too many lines. Select, split, click it one time, and then select the entity to be split. Okay. Now I'm going to go back and turn my selection on, and when I select that curve, notice it is broken right there. So now I have broken that arc into two arcs wherever it intersected that splitting entity. So that's one thing that's a little bit confusing at first for some, is that you need to select the entity that's going to be the break point first, and then the entity you want to break. Okay. Now, if I want to connect those two arcs back into one single entity, I will select both of them with multi-selection turned on, like this one, and I have join. And now, when I select that entity, so I've joined those, make sure selection is on. Now that is one entity. However, I want you guys to take note now that this is an entity, it's a polycurve. It's no longer an arc. It's not a true arc. It's actually a polycurve. So when we use that join feature, it doesn't join two arcs into one arc. It joins two arcs into a polycurve. Okay, that's just a little bit of a limitation for kind of what we've got going on here. Okay. Now, as long as you're aware of that, should be fine. Any polycurves can be used in contours. However, I wouldn't be able to select that and program a circle. It would force me to do it as a polycurve, or excuse me, a contour. Okay. So I'm going to cancel my selections right here, and I'll show you what it looks like to chamfer an entity. So before I chamfer an entity, I want to make sure that I have my the distance I want that chamfer to be set correctly. So I'm going to go up to the settings, and you'll see the settings tab drop down, and here is the chamfer distance or fillet radius, and we'll set that to 5 millimeters. I can go ahead and close that settings window. You can leave that settings window open. It just eats up some of the graphic screen real estate. But there's no issue with leaving it open as you continue to program along. I'll select chamfer. I'll select this line and this line, and it automatically applied that chamfer to the intersection of those two lines, okay? This chamfer and fillet are for 2D geometry. You can't apply a chamfer to a solid model that you've brought in. It would have needed to have that chamfer on it already, okay? So there is the chamfer, and I'm simply going to undo that by selecting undo and then redo to show you that. So now that we've drawn this, I will hit reset all to snap back to the full screen view. And I want to move on to a solid model now. If you guys have additional questions on 2D geometry creation or moving things around, I could also draw a quick line here and show you what that would look like if I put this line. If I want to connect it from here diagonally across to the other corner, I would need to turn snap on, snap to that end, and then snap to that end. And now I have created a line. Okay? Now, if I would like to edit that line, I simply turn the selection on and select that line, and now I have the input fields where I can actually edit that entity and say the endpoint is going to be here as opposed to where it currently is. You can also create a line in 3D space by telling it a z start of 0 and a z end as either a positive or negative value in this view, and actually you could create a cube, a wireframe of a cube here. It's not just 2D drawing. Cancel and undo that. Okay. So now I moved my origin, I programmed some features. Just like the DXF has always been, it is not, once the data block is created, it is not tied or constrained to this DXF file. So if I create a data block and then change the radius of a circle or scale it up or down, it does not change the data block that has been previously created. It leaves the data block alone. So as soon as you create that data block, it is no longer tied to this, which also gives customers the advantage of selling, or it gives us the advantage of potentially selling the desktop software because they can buy the 3D import option for the desktop. They don't necessarily have to buy it on the machine also. If they purchase it for the desktop, they can build programs and then save those programs to a USB device or send them over via a local network to their machine, and they don't have to have the 3D import option on the machine to use programs created on desktop software that does have the option. Okay? So I'm going to clear what we've got. So I'm going to select clear, and it asks, do I want to save changes? I'll just say no, and I'll clear that screen. I'm going to open back up my WinMax programming screen and create a new program. So I'll exit under Program Manager. We're going to create a new conversational program. And then we will go back to the graphic screen by selecting the other window. If you have a dual screen control or on your PC, you can simply drag one screen. Let me get rid of this. I've lost my window here. There it is. There it is. So now you can have both screens active at the same time if you have a dual screen control or on your desktop software. I'll keep this full screen. So now I'm going to import a solid model. So I'm going to select import. Again, it takes you to the last folder that you were working from, and I'll select the 5-axis cube. Here's the warning I mentioned earlier that you cannot export a step file or a solid model. You can only export out DXF files or wireframe geometry. Go ahead and OK to that message. And now we've loaded in a solid model. So I'm going to switch over to the isometric view and reset my view. So here I have a model with features on each face. So what I want to do is I want to program the top feature here. I'm going to turn my snap functions off. I've got my origin at the top dead center of the cube. Moving the origin is just like what we did in the DXF file, where I'm going to select and pick on that. And now I can go ahead and click where I want to move that part 0. So if I turn snap on, I can snap to that corner of the block, and it will automatically move that origin indicator to wherever I snap to, or wherever I have selected. Or again, without snap on, you just kind of free form where you're going to do that. Okay? So now I've moved my origin over to that corner, and I'll go ahead and start selecting some features. So I'm going to turn off. It was already off. Turn off. I'm going to go ahead and snap to, or go ahead and select this top surface. And notice now I have some block options created. So whenever you make a selection, it will highlight that selection. And if I want to select more than one piece of geometry or face at a time, I will need to toggle on the multi-selection. Even when the multi-selection is not turned on, you can use window select to select more than one feature at a time. Okay? You don't necessarily have to have multi-selection on when you're using window select. If I've selected too much and I don't want that selected, I can simply cancel under the actions section, and we'll deselect everything. So like I said, I will go ahead and select the top face of the part, and I get data block options that relate to that. So I'm going to go ahead and create a contour block, and it's prompting me to select the top of the feature for Z start, which is optional, but because I have a 3D part, I'll go ahead and make that selection now, simply by clicking on that top surface. Once I've selected that, I'll go ahead and approve that. And then it asks me to select the contour direction. I look at the top view. It's going to be hard to see with this color, but there is an indicator arrow showing the direction of that. Oh, here it is, right out here. Let's see if I can hide this. There it is. It's right there. Yeah, it'll show at the beginning of a contour. So on this one, it started at the origin, the front left corner. And I'm just going to go ahead and approve that. I can always reverse the contour later from the review screen if I don't like the direction, climb, or conventional milling one way or the other. So once I've selected that, it prompts me with a text box that says that the 3D DXF block was imported at the end of the program. So I'll go ahead and hit OK. We'll take a look at my review screen. Notice, guys, I have 2 data blocks created, not just one. It gave me a mill contour, which is a pocket boundary, and then a mill contour pocket island. So it changed the outside 4 lines to create a boundary and then a pocket island to leave that pentagon shape standing in the center. Now, to go ahead and simulate this, I will need to go into block 1 and select a tool. And then right here, I can set expand boundary, which I'll show you in just a second. That's a relatively new feature. So now that I've selected a boundary, I've got my Z bottom, I've got my Z start, and then the contours are already pre-programmed for me. So I'm going to come back to the graphics screen, and I'm going to go ahead and simulate this. So there we can see I did not define stock geometry, so it's giving me a block big enough to encompass everything I'm doing. But I can see that if I spin that around, my tool is not clearing the entire top surface of that part. Okay? So we're going to need to go ahead and remove or expand that boundary. So I want to show you that as well. Back in my programming window, when you have the milling type set as pocket boundary, you get the option to expand that boundary. So we'll go ahead and select yes to expand the boundary, and then it asks for a distance to expand, and we'll go ahead and just say 6 millimeters. Now I'll come back to graphics and update my simulation. So now I've expanded that toolpath, and we can see that toolpath comes right out to the edge of the part, and that tool diameter will be large enough to clean that excess material off. Okay. So expand boundary, like I said, is a relatively new feature that you can use to go ahead and specify an expansion distance to make sure you're able to machine that top surface. So now on my review screen, I've got this programmed. Now I'm ready to program a feature on another side of the part. So this is where we would typically go ahead and insert a transform plane data block if we had a 5-axis machine, and rotate the plane to be on one of these other faces. I'm not going to move my origin. I'm simply going to select a feature on this face by using my select pick and then picking that surface. And I'm going to go ahead and create another contour data block. Now, when you pick a feature that's not on the top of the part, it's going to give you this transform plane Z direction. So it's asking me, again, it's prompting me with some text to confirm the transform plane Z direction. And simply by clicking on the center of it, it will toggle that between the two possible views. The Z is either going to be going away from this or towards this. Okay? So here we've got the positive Z direction oriented the way we would like to see it. Okay, and with that, I will go ahead and approve that. And now it's asking me to pick the Z top for, the top of the feature for Z start, which I can pick here. Again, that's an optional step. If you skip over this step, you'll simply need to type a value in the Z start field in the programming screen. I'm going to go ahead and approve this. And there again is my contour direction. Okay, if I'm rotating this around here, I can see that I would be climb milling around the inside of that pocket. So I'm going to go ahead and approve that selection. And now it's brought me back to the program review screen. Okay, it's giving me a box. Again, it's prompted on my other screen that the 3D DXF block was imported. And now we can see that it programs the contour in the pocket island, but it also programmed the transform plane. So if I take a look at that transform plane, it has shifted the origin point over to that feature, and then it has used the vector method to specify how that transform plane will then be oriented. So if you have a solid model, you don't necessarily have to program transform planes yourself or worry about how things are oriented. If you can select the feature, it will apply that transform plane automatically, and it will also automatically create the transform plane end with the necessary blocks in between those. Okay? So I'm going to go ahead and select block 4, and we'll go ahead and pick a tool. Again, I'll just use tool 1. And this time I'm not going to expand the boundary because it has a wall. I'm not cleaning off the whole surface there. So back over to the graphics screen, turn our simulation back on, and I did get an error that I have no space for the blend in and out moves. So I might need to select a smaller tool on element 0. Let me select the tool from the list, and here we've got we'll go with a 12 millimeter end mill. And we'll come back to our graphics and see if we have enough space now for this. So again, it's going to simulate the whole thing just like it was. Again, I did not set up stock geometry, so it's just kind of making a guess off the features I just programmed. And there again, it will go ahead and machine that surface. Okay. Okay. So as we build along, if you'd like to program another feature on this surface, I want you to keep in mind that the origin point is always showing the original origin point. It's never going to show me the transform plane coordinate location. Okay, so if I need to figure out where did it put that transform plane origin shift, I would actually have to look at the data block itself. So we'll select the block and go back to the transform plane block, and then we can see where it shifted that origin in X, Y, and Z. And you can then use that to program other features within the transform plane, or simply pick a feature and set the next, and go ahead and create the next data block, and it will automatically create a new transform plane based off of your selection. So I typically recommend just pick the feature that you want to machine and let the software program the transform plane, unless you already have in mind where you want it to be rotated to, and how you want to work from it, how you want to spin that around. Okay? All right. So let me just do real quick a holes block on the back side of the part here. So I'm going to turn my selections on. I'm going to select that. Let me zoom in here. And I can go ahead and select the inside of that. Now, if I want to select all these holes at once, I need to select multi-selection. Or you can press and hold the control key on your keyboard, and it will allow you to select more than one entity at a time, as long as you are holding that control key. Okay? So now I've selected all the holes on that side, and I want to go ahead and I can use either location holes or pattern holes. Let's put in locations. Again, because it's doing a transform plane, it says, okay, which way are these holes oriented? Which way is the positive direction? So that blue line is going to indicate positive Z. Okay, red will be positive X, green is positive Y. Okay, so we'll go ahead and approve that. And it's telling me what the Z start is going to be and what the bottom is going to be, because I selected the cylinder wall. If I had simply selected a circle, a 2D piece of geometry, I would have had to key in the Z start and the Z bottom. Whereas here, it's gone ahead and analyzed those cylinder walls that I selected, and it's figured out, okay, this is where I need to start in Z, and this is where I need to end. You may need to go into your Z start and add some nominal distance to that, because right now the way it's selected is it puts the Z start right on that surface. So that would mean that your tool would wrap it directly to the surface, which you typically want to stop, you know, a few hundred thousandths of an inch above or a few millimeters above, depending on your units. I'm going to go ahead and approve that. And it's saying adjust the endpoint. I don't need to adjust either one of those. And now it has created another transform plane data block, the holes data block with all 6 of those locations, and the transform plane end is programmed for me. So I need to go in and select a tool for this drilling operation. I can sort these alphabetically simply by touching on the word tool. Scroll up to the D's, and I'll just grab a 5mm drill. I didn't pay attention to what hole size that was. I believe it's an inch size, so we'll just go with a 5mm drill. Again, you may want to go ahead and increase that Z start. We might add 1mm to that, so we'll do 1 plus enter to add a millimeter to that value, or if you're an inch, whatever value you want to add. Okay, and then we can come back to the graphics screen and simulate everything. So when using the 3D import, you load your solid model, and you just start working through the features on that model. It's typically easier selecting one feature at a time or a series of common features like the holes. And we can go ahead and simulate all that. Now, when we're working on the top and then we do a transform plane to the right side or the back side of the part, it's important that if you go back to a simple 3-axis operation, so I'm going to go ahead and turn my selection back on and select this pocket, the floor of this pocket. I'll create a contour block. Pick my Z start. Again, it's prompting me down here with the text, guys. Try to get in the habit of looking down there until you get pretty comfortable with the software. So we'll select that top surface and go ahead and green check to approve. Contour direction, I see that it's coming towards me there, so I'm okay with that. Climb milling, and it created the data block, okay? So again, when we go back, excuse me, when we take a look at my review screen, it's put that mill contour at the bottom. Now, anybody that is very familiar with the five-sided programming or the conversational transform planes, you should know that the transform plane by itself commands no physical motion in the machine, okay? Nor does a transform plane end. It is the operation on that plane that sets the tool normal to that transform plane. So if I do a transform plane and then I have a mill contour at the bottom, let me select a tool for this. Let me get a mill. Bullnose mill is a 6.35 millimeter tool. So I'm simply selecting a tool. Come back to my graphics screen and I'll hit draw. So notice, guys, that it's giving me this giant stock geometry. We can already tell something doesn't look quite right. Okay? So what we've got here, guys, is there's my pocket boundary way, way out in space. Okay? So what has happened here is we have performed a transform plane, but we have not set the tilt and rotary axes back to 0. Okay? So we have a couple of options for fixing this that I want to point out to you. One of those would be to move this data block in the review screen, cut it, and then paste it at the beginning of the program before the first transform plane. The second option would be to insert a transform plane data block and leave it at zeros, a null transform plane, okay? That will set everything back to the original. Each transform plane is from the original work coordinate system, not from the previous transform plane. So by doing that, and I will also need this transform plane end, so I will copy it and paste it. Now, with that on a null transform plane, when we draw this, now everything will be programmed as it should be, okay? So that's two options. One, move the block before the transform plane. Two, put that block on a transform plane of its own with everything left at 0. Or the third and final option is a relatively new feature. It's been out for about a year and a half now, but every time I bring it up, I feel like I get a lot of questions on it. So I'm going to go to the utility screen. I'm going to go to user preferences. I'm going to take a look at the conversational settings. Oh, excuse me, part and tool settings. Part and tool settings. Here we have a selection. It says enable Workpiece transform. Yes or no. It is always set to no by default, but then can be turned on. And what it does is it activates a transform plane at the very beginning of the program with a transform plane at the very end. Now, you will never see this transform plane and transform plane end, but what it acts as a transform plane that when a feature is programmed, it looks to that plane and says, where is that one? So this is just a null transform plane. So I'm going to go ahead and toggle that to yes. I'm going to go back to my review screen, and I'm going to delete the transform plane that I had in here. Oh, excuse me, not the transform plane in. Cancel that. So this transform plane, we'll go ahead and delete that one. And we will go ahead and also delete this one. Okay? But even without that, now we should see that everything will render correctly. Because that enable workpiece transform sets a transform plane that is always active. Okay? It cannot be turned off. If you do a lot of NC or G code programming, I recommend leaving that set to no. It can cause unexpected issues. You will not be able to disable tool center point management. You will not be able to disable 5-axis linearization with that workpiece transform enabled. So if you're running G code and you want to cancel tool center point management, you can put an M129 code in your program, but it's going to be ignored because the control forces tool center point management on whenever a transform plane is active. And what that enable workpiece transform does is activate that transform plane at all times. Okay? So that's just a 5-sided part. Again, we could just continue building on that simply by selecting features. So I'm going to go ahead and select another feature. There we go. Select that surface. And this time I'm just going to program a frame. Again, it's going to ask me for the transform. Now this time I selected a frame as opposed to a contour because I didn't want it to create this as lines and arcs. I just wanted a frame data block. The only difference between, if it's a rectangular shape, you can use either one. Just know that a contour block will allow you to manipulate each individual entity, whereas a frame block, you're more constrained as to adjusting it by a length or a width and a given corner radius. So we'll approve the selection. We'll give it a Z start and approve. And now the data block is created, and it's got the transform plane to set it up. And notice that mill frame now. I can simply select the tool and tell it I want to do a pocket boundary with that. And turn on adaptive path here if I'd like to. Again, once the data block is created, it is in no way tied to the model or to the DXF file. It's its own separate thing at this point. And I'll go ahead and hit the draw key again to simulate through the whole thing. Oops, excuse me. And there it is. Okay. So if I then wanted to pocket out that circle, I simply select the floor of the circle and go ahead and continue right on programming. Okay? Okay, at this point, guys, I want to point out one more thing here, that the export key is locked out, so I can't export this if I had made any changes. You can only export that 2D geometry. But what I also want to do is I want to show you moving, rotating or transforming the origin point, where it is on the block. So what we're going to do is we're going to select that origin point. We'll zoom in there and go ahead and select it. Excuse me. Let me hide my simulation. Okay. Went ahead and hid that simulation so it cleaned it up a little bit. I'm just going to window select the whole thing. Now notice transform is not available. I cannot select it. If I click on it though, it prompts me with a message that snap to object is required to draw drafting entities in the ISO view. So we'll go ahead and turn snap to object on, and now you'll see that that transform key is available. When I select that, I need to select the center of rotation. So I can select the origin point, or I can select another point based on the snap features. And I get a little tool that looks like this. So now I can simply click and drag to rotate that part in space to wherever I want it to be, or even drag it left, right, front, back, up, down. Put it where you want it to be. Notice it's snapping to 45-degree increments here. If you know the angular value you need to move to, and it's not divisible by 45 degrees, you can use the input fields at the bottom edge or at the bottom center of the screen to manually type in the rotation angles that you want. This is the only place where you can scale the entities as well. Okay, so you'll need to use transform if you want to scale entities. It's contained in that same input field selection. Okay, once we've positioned it where we want to position it, however that may be, we're going to hit the green check to approve, and now we have moved that entity and rotated that entity relative to the origin. So the origin stayed where it was, but I shifted and rotated the solid to wherever I now wanted it to be. Okay? Now, when I hit the draw button to simulate this and turn my simulation back on, notice, guys, like I said, once those data blocks are created, they are no longer tied to this. Okay? So those programming features are based off of the origin point because I programmed them before I moved this. Okay, so if you need to move it or make a rotation, it's important that you move it and or make that rotation before creating the data blocks. And this was the same in the Max 4 DXF as well. Okay. Okay, guys. So let me clear this out. I'm going to hit clear, and it says your changes will be lost. We can't save changes made on the step file, so we'll just hit OK. And notice that the simulation is still there because the simulation is not part of the solid model. That's the same simulation as if we had programmed this all conversationally by hand in the traditional fashion. Okay? So to clear that, I can simply hit clear over here on the right side. Okay. I'm just going to import another model real quick and show you one more thing with the 4-axis flank. Same thing, can't export it as a step file. So here I have a feature or a 3D feature, and what I want to do is I want to position this so the way that it's going to be sitting in my machine tool. So I want it to be sitting upright. So in the XY view, I actually want to rotate that. So I'm going to go back to the isometric view and reset my views. And we're going to use that transform to go ahead and select my origin point, turn my snap options on. I don't know why it jumped over there. Okay. Turn my snap options on. Oh, excuse me, I've got this selected incorrectly here. So we select part 0, turn our snap options on, and I should get my transform. Okay. Cancel that here. Oh. Before you can transform it, you have to select it, the whole thing, not just the origin point. I'm not transforming the origin point. I'm transforming the entire model. So now I can select transform and select. Now I can't snap to that origin. It wants to snap to the end point. So what I'm going to do is I'm going to select center under my snap to object menu, and then I'll select here, and it's snapped to the center of that arc right there. Now I can grab and rotate around the x-axis 90 degrees. And go ahead and hit my green check to approve that move. Now when I look at the top view, that is how the part is going to be oriented in the machine. Okay? We're going to go ahead and assume that this is a 5-axis machine, and what I want to do now is I want to flank mill this wall right here. Okay? So typically you would need to program a transform plane and then program a contour. But we do have a create block option called sidewall contour. So I'll turn my selection on and my snap functions off so that I can select a few surfaces here. I'll select one and press and hold control to select more than one at a time. So I've selected those surfaces. And now I'll go ahead and select sidewall contour. When I pick sidewall contour, it then is going to apply a transform plane and allow me to specify the positive Z direction. And I'll approve that. Select the Z start, so I'll pick this surface. And the desired contour direction is moving down the wall in this direction. That is what I wanted. So approved. So the data block was created. Excuse me. So now what we want to take a look at here is the contour that it's given us. And I dumped it into the end of the existing program. We're just really quickly going to toss that stuff out and select the tool for the mill contour that I just created. So we'll pick tool 1 and we'll use cutter comp left. Now back in the graphics screen, I'm going to go ahead and run the simulation. Now notice that the top view is this way, but when you use sidewall contour, it goes ahead and applies a transform plane so that you can flank mill a wall that may not be in the current XY orientation. So it's not just flat features and holes that will get these transform planes, but we can also specify sidewall contours, and then we could add multi-passes in there or add additional pieces of geometry to that contour. Again, once that contour is created, you have control of manipulating that contour from the part programming screen by adding segments, removing segments, and or adjusting the start and end points of existing segments. Okay? So on this one, guys, we rotated the entire part using transform, and then we use sidewall contour to go ahead and define a transform plane and mill the sidewall of our part. Okay, I'm going to hit the review button here so we can take a look at that. There's that transform plane. Now, it always defaults to use vectors for the transform. And if you guys have any questions about how vectors work as opposed to angles, just shoot me an email or give me a call and I can go over that. I've got some documentation that helps explain that. But what this is going to be is the origin point and then a position in relative to X, Y, Z, and then a Y position relative to X, Y, Z for the positive X and positive Y direction. So it's 3 points to define a plane is what the vectors are doing. 3 points to define a plane. First point, and then this is an absolute point, whereas these are incremental points from the origin. Okay? All right, guys, I've gone a little bit longer than I wanted to. I want to open it up to some questions here. So I see there are, yeah, so I see, Philippe, I believe your question about the rotation. If you guys could just type your questions in that text bubble, then I'll try to answer them one at a time. It may be easier than trying to all talk over each other. So Philippe asked the question, what about the rotation of part 0? Okay, so the rotation of part 0 there would be done with the transform, but you would only select part 0. You would not select the entire model, okay? You wouldn't select the entire model when you do that. And then, is it available with angles? No, it is not. It is not going to give us angles. It will only give us vectors. So I think I kind of answered that question as we went there. Can I use window select to select more holes? Yes, you can. That's a great question, Toke. So let me show you guys something with that. So earlier in my presentation, I talked about the filter circle radius, okay? So that filter circle radius allows me to window select and filter out the radius that I want to see. So if I pick on, I'm going to pick on this, not that feature, look at the outside wall. So I'm going to zoom in here a little bit, and we'll grab the inside of this hole. So I'm going to select the inside of that hole. So I've got the wall. Now right here, guys, notice set R is available. Set R is available, okay? So right now my filter circle radius is 0.1969 millimeters. But if I hit set R, it will update that filter. It will automatically set that circle radius to whatever I have selected. So I can simply select one hole or one arc, and then when I hit set R, it will automatically set that filter circle radius. Now that that is set for us, I can zoom out, and Toke, to answer your question more specifically, you will need to have the filter circle radius box checked, and then we'll simply window select over the part, and now we can see that it has selected all three of those holes of a like size, okay? If this filter circle radius is not selected, it will go ahead and select everything within the selection window, okay? I hope that answers your question, Toke. Are there any other questions? Does anybody have? I will be sending out an email with a link to this slideshow, these sample files, and the DXF file for all of you guys shortly after this meeting. I didn't have a chance to get the link created yet this morning, so I will send this link out to you. Okay, so on the DXF file, is there a way to edit the start point of a contour? Yes, there is. Okay, so let me go back to that. Well, let me pull up the DXF file so I've cleared out what we've got. Okay, we'll jump to that top view. Oh. Okay, so let me hide a few of these layers again so that we can kind of see this a little bit cleaner. Okay, so I want to chain this contour around the outside, and the question is, can we edit that start point? So I'm going to turn my selection on, and I'm going to turn on chain selections so that when I pick that contour, it's going to go ahead and chain that entire contour. So the easiest way to make sure where you want it to start and stop is turn your snap functions on and set it to end. And then as you cursor over that contour, it'll snap to the end point of one of the pieces of geometry, whether it be the line or the arc. So wherever that snap to is, when you select the geometry, that is where the start point is going to be. Does that answer your question, or are you asking if you can edit it after you've made the block? Hendrick. Okay. So there it is, right there, guys. Is it new? Is what new? The ability to snap to set that? 7946. Yes, it is. Yes, the 130. So 10.2.130, guys, is still beta software right now. I will send you a link to download it so you guys have all the desktop software. But yes, so there were a lot of enhancements and a few behavior changes implemented going from 79 to 130 branches. Okay, so you may You may have a little bit, if you're trying to follow along and you're on the latest released software, 7946, yes, I believe most of the functionality was there, but they have definitely improved it and made a few slight behavioral changes. But I can send you a link to download that, along with the release notes, enhancements, bug fixes, and otherwise. So I'll get that out to you. Max, this was not possible before the SW version. Yes, that's correct. The software version. Yes, yeah, 10, yeah, the 3D import is not available unless they're on 10.2 or newer, and all the latest fixes and enhancements are in the 10.2.130 branch. Okay, so previous to the 130, the start point of the contour was random. Okay, Florian just added that. Okay. This procedure also introduced at a step file. Max, good question. Max asked, can we specify the start point like this on a step file and not just a DXF file? So let me pull the step file back up and we will check it out here together. So let me go to the isometric view and reset that. Okay, so we're going to go ahead and select, and I'm going to go ahead and select this surface, but notice my snap function is on. Okay, well, let me do a different corner because that's where it picked it last time. So my snap function is on, and I'm going to pick this back corner. Yeah, I'll pick this back corner right here and go ahead and create the contour block and just skip over the Z start and the contour. No, it did not allow me, Max. I believe that is not available on a step file. I kind of clicked the check box a couple of times fairly quickly, but the contour that it just created started at the front left instead of the back right, which is where I selected nearer to. Okay, so no, it doesn't look like you can do that on a step file right now. Okay, a possible workaround would be to go ahead and create some 2D geometry. So let me just show you guys creating some geometry on a new level. Okay, so I'm going to go, or excuse me, a new layer. So I'm going to go down to layers, and I'm going to hit the little button, and I'm going to say add a layer. Okay, it gives me a name, and I can edit that name right here. And again, I'm looking to the extreme lower left of the screen. So we'll call this 2D Geo, and we'll go ahead and set the color as red so that it stands out for us. Now, because this is the last layer I clicked on over here, it is the active layer. That's the only way I know that. There's nothing to indicate that it is. But what I'm going to do now is on the draw functions, and the snap functions are on, I'm going to draw a line, a contour from here to here, another one from there to there. All right, guys, so I'm just creating a corner. I'm clicking on the corner. I'm using the snap functions to make sure that I am selecting the correct corners. Now I've created those. I'm going to turn my other layers off. So now I have 2D geometry made from the solid. And once it's 2D geometry, then you can specify the start point. So that's going to be your workaround, Max. You could also insert a change parameters block with a changed pocket entry position as a workaround. Yes, Florian also brought up a good point that you can specify the pocket start if it is a pocket, okay? So the way that this operation was created was as a pocket boundary with a pocket island. So let's take a look at the part programming screen in pocket boundary. In that part, we can specify a pocket start. To do that, the pocketing type must be set to inward or adaptive path. And then under program parameters, on the milling to tab, the operator can turn on the ability to specify a pocket start. So if I set that to yes and return back to my part programming, excuse me, I now can specify an X and a Y plunge point for the pocket start. Florian, but I guess the question, yeah, so the question, I think the original question, guys, was, yeah, the DXF file or 2D geometry, can you specify where that starts and ends? So yes, you can on 2D geometry. You got to get a little bit more creative on solid models. Any other questions? Comments or concerns? Okay, everyone, I want to thank you guys so much for your attendance. I'm going to go ahead and put my contact information up on the screen. I believe you guys should have it, but I want to make sure you have it here. Okay, so here is my contact. Oh, yes, I can wait. Yep, Max, I can hold on.
Yeah, just before you end, how do you accommodate for selecting holes of a different depth if they're on the same face?
Okay, so if you have holes, and so if the holes are the same diameter on the same face with a different Z depth, you will need to select them individually. Okay, you'll need to select them individually, and let me pull that up, excuse me, for you here. So the way that and that is more a limitation of the holes block itself. So if 3 of these holes had a different depth than the other 3, so let's just say these top 2 holes have a different depth than the bottom 4, that would have to be specified in a separate holes block. Because the way the holes block functions, and again, this is a limitation of the holes block itself, is when we insert holes drill operations, I can only specify 1 Z bottom at, you know, any number of locations. So I can't specify 2 different Z bottoms in the same data block. So what we would need to do then is you would just have to either limit your window so that when you did a window select, I'll go to the go to here. I would actually just try to window back on it. I'm in the middle of an operation, so I got to cancel my operation. Okay, so select box. So I would limit my window like that to select only those 4 holes, but you can't. There's no way to pick all 6 of them and say 2 of them are a different depth than the other 4.
Just another question. When you pick the holes, you have the option to increase the Z start by an incremental distance?
Yeah, so that can be done. That can be done either in the data block itself, but if you want to update it for, let's say, 4 or 5 blocks at a time, and you don't want to go into each one individually, we will use the copy and change blocks from the input screen, modify dimensions, and then the Z offset, you'll apply the new Z offset and then make the change. Unfortunately, it's not an incremental change. It's an absolute value. So if you're going to be changing it for multiple blocks, it's important that the Z start, you know, can all be the same.
Is there any way of putting that in as a parameter, as an incremental distance? So it adds it to the Z start of whatever feature you select?
Yeah, so I'm taking a few notes right now to write up some enhancement requests. And as you guys play with this, once I get this new software out to you, you know, anything that you think of like this, you know, if you're wondering if it's not there and you can't find it, shoot me an email and let me know. And if it doesn't exist, I'll go ahead and write it up, and I will reply to you with the ticket number or the enhancement number, so that you can track that change through the ADO interface that way. But as of right now, it's just modified dimensions. This is I mean, I believe that this screen has been around since Ultimax, so it's nothing new, but I will go ahead and write that up and let you know. Okay. Philippe had a question he wrote in. He asked, do we have any news about the 3D block? And what he means is the 3D surfacing data block. We are testing some things with the 3D surfacing block now. It will be supported in this version, 10.2.130.12. But the way we have it set up right now is it's a hidden option that while we're working through some of the bugs and testing, it's hidden. We've actually got to run a little script of a command script to actually activate it. But we are working on it. I just don't have it enabled right now to show you guys. So I can send you some screenshots once I can get it enabled. But that should be coming hopefully in the next few months to beta customers. Max has a question. He wants to combine a profile as sidewalls. Is there any possibility to act like a constant Z continuation when I click on the solid edges? For example, when you use the constant Z continuation at solid cam set system. Okay, so the constant Z just being a constant Z level as it works around that part. Unfortunately, right now you will need to, that would be done just with pet depths, but it's not going to continuously just to profile around and down. Does that answer your question, Max? Matt had a question. Matt asked what type of 3D milling cycles will be available. So what we have so far is selecting a single surface or a few surfaces at one time, and the toolpath options are going to be spiral and raster as of this point. So a parallel toolpath. So just a parallel, either one way or two-way zigzag, and then you can adjust the angle at which that parallel toolpath goes. And then the other would be to use a spiral, like a parametric offset. So it would take the boundary of that surface and spiral either inward or outward to it based on your selection.
Are we still restricted to ball nose cutters? Or can we use ball?
Right now, we are restricted to ball nose. However, there will be the availability to use bull nose if you have enough of an angle on your part. So I don't have it enabled here, but what I can show you is that, so right now the origin is straight up. This top surface is flat in the XY plane. What I could do is I could rotate the part 45 degrees and then select that surface. So it will apply a transform plane, and then it will take that parallel toolpath or that spiral toolpath, and then it will allow you to do it with the side or out on the radius away from the tip of the ball end mill. So you're not limited to keeping the tool normal to the surface. You can actually tilt the tool 20 or 30 or 40 degrees and then use use the radius of the end mill to surface as opposed to using the tip of a ball end mill. But right now, I think we're still working through the ball end mill stuff. But we do plan on supporting bull nose tools eventually. Okay. Philippe asked, finish block included, and I'm assuming you mean, can we create a, yes, the finishing for the 3D stuff. Yeah, the finish block is included in that. It's all. So Max, back to Max's question, we're working about the constant Z. So just so everybody can everybody read these comments in the chat? You guys can. Okay, I've got a few people here. I'll just read them off. So imagine sidewall milling from a profile. The normal way would be to click on every surface with the activated multi-selection. This takes several seconds between clicking and rotating the piece. From my opinion, it would be easier to click on the solid edge, bottom line of the profile, and then an additional function to auto-select all other solid edges in the same Z level. Max, no, we don't have that right now, but that's a great thought. So I will write that up as well. I think the only way to do kind of what you're thinking about right now, Max, would be to create 2D geometry using the draw functions. And then when you select that, you can basically project those onto a surface. So if the part had a Z start of 1 and 1 and then it dropped down or raised up, once you created those entities, you could go into the input fields at the bottom center of the screen with those entities selected and set the start and end to Z0 on all of them, and it would put them all on one plane. And then you could use Z start and Z bottom. I know that's pretty cumbersome, but that would be the workaround until we can implement something different. Okay. Okay, guys. If you need to run, I know I scheduled this for 2 hours. I know you guys over in Southeast Asia and China, it's probably getting pretty late. I really appreciate your time. Philippe, do you have an option for surfacing from the step file? Yes, Philippe, we can surface directly from a step file. So simply select the surface that you want to machine. That's the way it'll work in the 3D. With the 3D surfacing. Like I said, guys, I'll hang around here for another 15 minutes or so, 10, 15 minutes. If you have additional questions, just keep rolling them in and I'll address them as we go. If you need to go, like I said, go ahead and take off. And you can also email me. I hope everybody has my contact information. If you don't, I will leave it on the screen. Also, guys, be thinking about topics for next quarter. I want to put another one of these together. I will send out when I send out the link for the desktop software and all the files, associated files. I will go ahead and go ahead and say, you know, start sending me some topics, and we'll put that on the schedule for next quarter. So, like I said, if you need to go ahead. We got one more question. Any chance that 3D solid model will run in another type of program besides universal type? No, is the answer to that. Universal program types is you're going to be locked in. So you can't use rotary A or tilt A, rotary C. You are going to be locked in at the universal program types. And it hasn't happened yet, guys, but these other program types are going to be going away. I don't know when, but as this new stuff starts to roll in, you are going to be forced to always use the universal program type.
Universal code, every 3